Hey guys, this is Mrs. Bolin, and I'm going to go over the sampling distributions for sample means. So you guys need to make sure that you're looking at the problem and see if it's talking about a proportion or if it's talking about a mean or an average. If it's using a proportion, be sure to use the formulas that we talked about in the other video. If it is talking about a sample mean, then these are all the formulas that you will need. So our parameter would be mu, which is the true mean. And again, we're going to start with one sample. And then after we get through those types of problems, we'll look at the formulas that we would be using for two samples. So our parameter was mu, which is the true mean. The statistic we're looking at is x bar, which represents the sample mean. The mean of the sampling distribution of size n would be mu of x, and that's going to be equal to the true mean. Okay, so the mean of the sampling distribution is an unbiased estimator for our true mean. So just making sure that you look back to the original problem to see what the mean was for the population. The standard deviation then is the standard deviation for the population, but as we take samples of size n, that decreases the standard deviation. So you're going to take the square root of n and divide the standard deviation by that value. So as n increases, the standard deviation decreases. And then we'll get into the central limit theorem in just a minute, but we want to make sure that we're allowed to use this formula, and the way that we can check for that is by meeting the 10% condition, making sure that our sample size is smaller than 1/10 of the population. Or you could clear the equation of the fractions by multiplying by 10 on both sides, 10 times the sample size, making sure that that's smaller than the population. So two different ways to look at the same thing there. When is the sampling distribution approximately normal? Well, we can meet one of two requirements. If the population is approximately normal, then we know that the sampling distribution will be approximately normal regardless of your sample size n. However, if the population is skewed left, skewed right, something weird going on with it, we know that as long as n is large enough, and in this case, according to the central limit theorem, if n is greater than or equal to 30, we can safely say that the sampling distribution will be approximately normal. So either one of those conditions can be met. Sometimes both conditions are met, but you want to make sure that you're clear to state at least one of those when you say that the shape of the distribution is approximately normal. The z-score formula, if we're standardizing that value, we're going to take our sample statistic, x bar, subtract the population parameter, which happens to be mu, and divide by the standard deviation for that sample size. We only need to do this if we're using table A or if we're plugging in 0 and 1 for the mean and standard deviation in either Stapplet.com or normal CDF if you're using a TI 83, 84, one of those ones. Again, if we're using Stapplet.com and plugging in our parameters for mean and standard deviation, you do not need to find the z-score first. So what happens then if we have two samples? We're looking at the difference between the means in those samples. So our parameter that we're looking at is mu1 minus mu2, and that is the true difference in means. Our statistic then would be x bar 1 or x1 bar, take away x2 bar, and that's the difference in sample means. Then if we look at the mean of the sampling distribution of those differences, we know that the average of that, or the mean of that, will be this true difference in means. Our standard deviation, you're going to need to plug in for your two different sample sizes and your two different standard deviations there. Then we would also check the 10% condition for both samples, making sure that the samples are independent of each other and making sure that our sample size is less than 1/10 of our population. And then for both populations or samples, you need to make sure that either the population is approximately normal or the sample size is greater than or equal to 30, and you need to check that for both of the populations or samples. Then finally, we have the formula here for z-score, which is always our sample statistic